All right, this is your video for the 8.1 to 8.3 review. I apologize for my voice. I have no clone and I'm sick, so this is the best I can do. So we've got different graphs in all of our sections. If we look at this first one, the b value is bigger than 1, so that means this is exponential growth, meaning that generally the values get bigger as we go on. However, when we have a negative a, it flips the graph, so you should know by looking at this that this is going to flip over the x-axis. So remember that we should always find out where our asymptote is, and our asymptote is always at our k value. So since exponential growth and decay have the a, b to the x minus h plus k, if I look at that value, there is no plus k on the end, so that means it's 0. So if k is 0, that means my asymptote is going to be at y equals 0. So I can graph that on there. There's my asymptote. So now when I go to graph, I need to find my starting point. My starting point is going to be at 0a and then shifted based on h and k. So here my a is negative 1/4. So that means I'm going to start at 0, negative 1/4. And since h and k are both 0, that starting point doesn't get shifted any at all. So 0, negative 1/4 is going to be where my graph starts and where I start my t-chart. So that means I want to pick some values around when x is 0. When x is 0, if I plug it in, 3 to the 0 power is 1 times negative 1/4 is indeed negative 1/4. So I just checked my starting point there. When I plug in 1, that's negative 1/4 times 3 to the first. So negative 1/4 times 3 is negative 3/4. So 1, negative 3/4. When I plug in negative 1, negative 1/4 times 3 to the negative first. Remember our negative exponent rules. That is negative 1/4 times 1/3, because 3 to the negative first is 1/3. So that gives me negative 1/12. Now, I have said on these that generally we want at least 4 points. You can already tell that the more negative ones are just going to get closer to 0. It's very hard to graph. So I would pick another value over here somewhere. So pick 2 or 3 or 4 or whatever. So let's just say I go right up and pick 2. So negative 1/4 times 3 squared. So negative 1/4 times 9 is negative 9/4. So 2 and negative 2 1/4. So there are my points. I can connect it to draw my graph. Very important couple things. First of all, make sure you drew the asymptote. It is part of the graph and it has to be there. It's part of the graph. Secondly, I see a lot of people get sloppy when they connect. Remember that an asymptote is a line that the graph approaches but never actually reaches. I always have people cross the asymptote when they connect their, other points to finish the graph. Don't do that because it's actually wrong. It never crosses this line. So just like that, now we just need to fill in domain and range. Domain, it goes on forever this way. It goes on forever this way. So all real numbers. The range, remember, is always connected to the asymptote because the y values are either going to be all above the asymptote or all below. And you can look at the graph to figure out which one. This one, they're all below the asymptote. So below means a less than symbol. And the asymptote value was 0. So all reals less than 0. All right, let's try it again over here. Again, my h value is 0 because I don't have anything up here. My k value is negative 4. So that means that's where my asymptote is. Y equals negative 4. Now notice this graph doesn't go down to negative 4. So some of you might have been confused on my answer key. I counted by 2s. So if you look at the back of your worksheet, the graph that I've got on there is counting by twos. Just to be different, for those of you who extended the graph, I'm just going to draw it one down. So if you counted by twos, great. You should be able to see the actual graph on the back that does like that. Otherwise, some people I saw just counting one more down to get their asymptote. So there's my asymptote. Now I need to figure out where my starting point is. So my A value is 2, so it would start at 0, 2. My H value is 0, so I don't change that. My K value is -4, so I am going to change my Y, so 0 plus 0 is 0, 2 minus 4 is -2. So the starting point on my graph is going to be 0, -2. So again, if you're counting by twos, that would look a little bit different, but here counting by ones, there's 0, -2. So now I'm going to make my chart. And I know that I'm starting there at 0. And again, when I plug in 0, I do get 2 minus 4, which is -2. So I'm going to pick -1 and +1 and see what happens. So I've got 2 1/3 to the -1st minus 4. So 1/3 to the -1st, remember negative exponents you flip. So this becomes 3/1 to the first power. 2 times 3 is 6, minus 4 is 2. So -1, 2. 1, 2 times 1/3 is 2/3. So then I've got 2/3 take away 4. Now you can use your graphing calculator to help you if you don't know that, or you can get a common denominator, but it's -3 and 1/3, or -10/3 if you're listing it as an improper. So 1, -3 and 1/3, so right down here. So we can see again we're already getting very close to this asymptote over here, so I would probably pick my fourth point in the negative direction at -2 and see if it fits. So -2, 1/3 to the -2nd is going to be 3/1 to the second, so 9. 2 times 9 is 18, minus 4 is 14. So that is way off the graph. It's too big. So if you want to pick a +2 and get 2/9 minus 4, you can certainly do that. It's very, very small. Or you can just leave 3, because in that case, there aren't 4 significant points to connect. So again, remember that when you connect this, do not cross that blue asymptote there. It gets close and close and close and close, but it never actually touches. So there's what your graph looks like. Domain, as it is in all of them, all reals, because the x's go on forever both ways on the x-axis. The y is always connected to the asymptote. In this case, the graph is above it. So all reals greater than the asymptote. Don't know what happened there, sorry. The third graph, this one is all in the graphing calculator because our base is e, and most of us can't do that in our head to make points. So later when we take a non-calculator parent graph quiz where you're not allowed to use your graphing calculator, this one will not be on it because e's are just a different thing. So we're going to be using the graphing calculator for this one. So you punch into your y equals e to the x plus 2. And you can graph it to see what it looks like. You should know where the asymptote is at least, because the same holds true for all of the asymptotes. This one's going to be at y equals 2 because that's my k value. So to get the points on this one, I'm not picking them by hand. I'm actually just copying them out of my table. Remember, you get that by pressing second graph once you've graphed it. So I usually start at 0 when x is 0. Y is 3, so that seems like a good place to start my graph. I know that my asymptote is at y equals 2, so I can graph that in. And so then I just look at the values and copy them down from my table. So at positive 1, I've got about 4.718. At positive 2, I've got 9.39. At negative 1, I've got 2.36. And at negative 2, I've got 2.13. So I can graph all of those points. So negative 2, 2.13. So very small right here next to the asymptote. Negative 1, 2.36, so not even quite to a half yet. 1 is 4.7, so almost to 5. And 2 shoots all the way up to 9.39, so 2, 4, 6, 8, 9, and almost a half. So there are my points. Again, when you connect them, please don't cross the asymptote. There's what my graph looks like. Domain, as with all of them, is all reals because it goes on forever both ways on the x-axis. The range, it's above the asymptote, so that means greater than 2 is going to be that. The rest of the problems that are not graphs, you're going to be using these formulas. And yes, for those of you who asked in class today, these formulas will be given to you. But remember, you have to know what the variables stand for. So if you don't know what the variables stand for, that doesn't do you any good. You have to know what formula to use and what the variables stand for. So you should know that this is compound interest. This is exponential growth. This is exponential decay. And this is continuously compounded interest. So if the problem is talking about interest, it's either this one or this one. It's only the part if it says continuously, otherwise it's this one. If it doesn't say interest, then it's either increasing with exponential growth or decreasing with exponential decay. So I'm going to set up these, but I'm not going to solve all of them because you know what the answers should be, so I'll do 2 of the 4 here. But it says you deposit $2,000 into an account that pays 5% annual interest. Write a model and find the balance after 2 years if the interest is compounded, and then it tells you all the differences. Now, on my key, I didn't write out the model because that's part of your work, but it'll be separate on the quiz. And when it says write a model, that means, and I said this in the notes both times, you have to leave time as a variable. You don't plug it in for the model. So I'm going to do quarterly and continuously maybe. So for a quarterly model, it's compound interest that's not continuous, so it's this formula. So P stands for the principal, how much I put in. So that's 2,000. 1 plus R is the interest rate as a decimal. 5% as a decimal is 0.05. So 0.05 over N. Again, you can look back at your notes. If you don't know what these variables stand for, you need to study them. But N is the number of times compounded. So this quarterly means 4 times a year, so this is 4. Raised to the, again, on a model, you leave time as a variable. So don't plug in 2 for t in the time. So N is 4. So 4t. And then I just need to simplify to get my final answer on the model. So simplify this in here. So 0.05 divided by 4 is 0.0125 plus 1 is 1.0125. And then that's to the 4t. This would be your answer for the model right here. Then find the balance after 2 years. So now you plug in the 2 and actually solve. So 4 times 2 is 8, and that should give you your answer that is on the answer key, which is 2,208 and 97 cents. So continuously is the one that's the PERT formula. So P is still for principal, E is the natural base E, R is the interest rate, and T is time. Again, for the model part, when I write the model, I leave T as a variable. So P, principal, is 2,000. E to the interest rate is 0.05, so 0.05 T. So these ones are actually easier. There's a lot less to do and simplify. This is our model. And so then after 2 years, I plug in 2 for T. So 0.05 times 2 is 0.1. So you're pressing into your calculator 2,000 E to the 0.1. Please make sure you are showing me your work on your quiz so I know what you did. Otherwise, I'm just going to assume you copied it from your neighbor. And so there would be your answer for continuously. Annually and monthly, you use this again, but annually N is 1, monthly N is 12. Which type of compounding yields the greatest balance? That would be continuously. The smallest balance would be annually. Number 5, the wholesale price of a 1-carat diamond ring in 2000 was $15,100. The price has increased by 4.5% each year. Write a model and find the wholesale price in 2013. So again, write a model means leave T. Now, this is not interest. It doesn't say interest anywhere. It just says it's increasing, which means this is exponential growth. So again, you have to know which formula to use. So exponential growth is this one right here. A is my initial value. So that'd be 15,100. That's my initial value. Then it's 1 plus R. So the increase rate is 4.5%, which is 0.045. Raised to the T, because again, in models, I leave T as a variable. So that's why my answer for the model says 15,100. You have to simplify it for your model, 1.045 to the T. So now, after I find the model, the wholesale price in 2013. This was in the year 2000. 2013 is 13 years after 2000, so that just means I plug in 13 to my model, and that's how I get about 26,760 cents. Whenever we are talking about money, you should always round to the nearest cent. So always to the nearest cent. Number 6, from 1990 through 1998, the value of the dollar was shrinking. Obviously not in the United States, a dollar was still a dollar. We're talking globally here. The shrinking value can be modeled by this equation where T is the number of years since 1980. Notice that it's asking you, it's testing, do you know what the variables stand for? So here I gave you the model. I want to know that you understand and can interpret it. What's the initial amount? Well, that's always what's in front. It's 1.24. What's the decay factor? Again, you're only going to know this if you've studied your notes. It says in all of the notes what each of the pieces stand for. The decay factor is whatever the base is. So 0.973. Now, what that means is 97.3% is how much of its original value it was worth after each year, if that makes any sense. What is the annual percent of decrease? Again, this is exponential decay because it's shrinking. So if we're looking at the exponential decay formula, which is right here, A times 1 minus R raised to the T. R, it's asking for the percent decrease. That's R. Now, notice here I don't have 1 minus because I simplify it when I do a model. But I know that whatever is in parentheses is my 1 minus R. So set that up. 1 minus R equals my parenthesis. Now I can solve for r, so subtract 1. That gives me negative r equals negative 0.027. So r equals 0.027. Notice it said percent of decrease. So I need to change this to a percent by multiplying by 100. So 2.7% is the amount, the percentage it was decreasing by each year. So then finally, what was the value of the dollar in 1998? Now it's asking me to plug in 8 for t. So 1.24 times 0.973 to the 8th power. Now, I had some questions for those of you who finished the review in class. A couple people asked me about this because you got this and you were confused as to why my answer key said $1. Again, we're talking money here, and this isn't the best example because it does round up to $1, but you would have to have the work to back it up. Whenever we're talking money, unless it says otherwise, you round to the nearest cent, and the nearest cent is $1. So this is your work. Your work's going to show, no, it's not exactly $1, but when I round it to the nearest cent, it becomes approximately $1. All right, the last one, simplifying these expressions, this is all just exponent rules. The only difference is we've got a base of e. So this is power of a power. When you have power of a power, you multiply the exponents. 4 times negative 2 is negative 8. Can't leave negative exponents in our answer, so we reciprocal them and make the exponent positive. So that's how I got that answer. Here, I have coefficients and e's. Deal with them separately. If I just had 3 over 9, I would reduce that to 1 over 3. So do that first, then look at my e's. My e's, the rule with division of powers is to subtract the exponents. When nothing is written, it's understood to be a 1. So I subtract 5 minus 1 is 4. So 1 e to the 4th over 3. In my final answer, I take away that unnecessary 1. So e to the 4th over 3. Here, again, is power of a power, but I need to remember that everything in the parentheses gets the exponent. So not only do I need to remember to multiply these, but I need to remember to square the 4. So that's how I come up with 16. This one, it's multiplication. Again, deal with the numbers and the e's separately. 2 times negative 3 is negative 6. Now deal with your e's. When you have multiplication of powers, you add the exponents. So I'm going to add x plus this exponent, x plus 3. Now that simplifies. These are like terms. X plus x is 2x. So that's going to become 2x plus 3. Again, exponent rules that you learned in Algebra 1 that we've reviewed twice this year. You really need to know them because they keep coming back if you don't. 11, negative exponent rules means I need to take the reciprocal, 2 over e, and then make the exponent positive. So anything to the first power is just itself, so 2 over e is my final answer. Last one, this is a jailbreak problem. I tried to make it pretty easy. Square root of 64, you should know that, is 8. Now, this is a jailbreak. Remember, whatever the index is, in this case 2, you need groups of 2 in order for them to break out. E to the 6x, remember, is just this with 6 e to the x's because it's like thinking backward. If you were multiplying these, you would add the exponents, x plus x plus x plus x plus x plus x. This is the same thing as this. These are equivalent expressions. So if I want a jailbreak, I have to have pairs in order to bring one out. So here's a pair, here's a pair, and here's a pair. I have 3 pairs of e to the x's. So that means 3 of those e to the x's get to come out. So e to the 3x. All right, that should cover just about everything. Again, reminders, show all of your work Know what the variables in the formula stand for. And please, 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 on your graphing, show your work. Don't cross the asymptote. Make sure you draw the asymptote, and make sure when you list the asymptote that you do it as a line. Don't just put 0. 0 isn't the asymptote. The asymptote is the line y equals 0. So again, be specific. That is it. Happy studying.